All right, everybody, we are going to talk about research, participants, and sampling. Just a little introduction to that idea. Um, and we're going to start off talking about the difference between a population, a sample, and a census. The population is all persons of interest. So if we're doing childhood apraxia of speech, right, the population would be all children with apraxia of speech in the world. The sample, though, is the people who are actually in the study. So this study examined 20 children with CAS, right? Those 20 children are the sample. Likewise, if you're doing a study on adults with aphasia, this study examined 40 adults with aphasia, right? Those 40 adults are the sample and the sample size. A census would be information from the entire population. So if you were getting information on every kindergarten student in Watauga County, and it was, you were able to get in touch with all the kindergarten students. This study included all 240 kindergartners in Watauga County, North Carolina. That then is actually a census. If you're if you're talking about kindergartners in Watauga County, because you've got them all. So researchers study a sample to draw conclusions about a population and to be able to make inferences and infer that, all right, well, we found this information about the sample, and we're going to infer that information to the population at large. So conclusions are indirect and not based on the entire population. So, are the 20 people in your study, if you found some kind of therapy is helpful for them, for that sample, is it helpful for the whole population, right? That's what we've got to think about, and wonder, how confident are we one way or another? If you have data from the entire population, so the data from the census will be called the parameters. The data from a sample in a research study is statistics. It's important to remember that there's always bias in samples. A truly unbiased sample, which I guess would be the gold standard, is that all members of a population have an equal chance of being selected. In reality, that's almost impossible. And so there's always bias. There's always bias in all samples. Number one, you're never going to be able to identify all members, right? If you're looking at children with apraxia of speech, right? There are kids out there. There are probably kids in Watauga County who have childhood apraxia of speech who are not identified and diagnosed, let alone kids in the country and the world. We'll often have a sample of convenience, right? That if we're doing a study here in Boone on childhood apraxia of speech, right, we're going to get people from the county, from the state, maybe from East Tennessee, right? But that's probably as far as we're going to be able to go. It's going to be a sample of convenience, and not, there certainly is not the idea that the whole population can be equally selected. And then we have the idea of volunteerism, right? Even if we can identify people for the study, a lot of people are going to turn the chance to be in the study down, right? Whether that's because they don't have transportation, they've got jobs at different times, they need childcare or don't have childcare, or whatever the reason, right? There are a million reasons why people would be more likely or less likely to be in a study, which means that, people have a very unequal chance of actually being in the study itself. All right, so now we're going to talk about some sampling methods. And we'll start off, we're going to really focus on random selection here. So there are a couple different ways to do random selection. One is simple random sampling, It's the most commonly used method. And this is where every member has an equal chance of being selected. And what we're going to do here is we're just going to use random numbers to decide who is in our study and who is not. All right, so if we go back to our course here, and we go to our random number generator website. This is kind of cool if you want to play around with this a little bit. Right, but one thing we can do is, right, they've got all kinds of different things here. They've got a coin flipper, a dice roller, playing card shuffler. But for research wise, right, we're going to go to integer generator. All right, so let's look at our class for a second. So here's the first names of everybody in our class. Let's make that maybe a little bit bigger. So we've got a class of 21, and let's say I'm going to do a study with 16 people. So how can we decide who the 16 people are in our class? So we're going to take 16 random integers. We're going to have a value between 1 and 100. Let's make it 1 and 500 just so we don't get any duplicates. We're going to do one column, and we're going to get numbers. All right, so those are our randomly chosen numbers here. We're going to copy that. I'm going to go back to our spreadsheet. I'm going to paste that in. Whoops, that didn't work at all. I needed 21. Ha, just kidding. All right, we're going to go back. So that's a good lesson. We need to have numbers for every participant, not just, or every possibility, not just how many people we need. All right, now we've got a number for everybody. That's better. Copy that one. Now we'll go here. Now we'll paste. Good. So now we've got numbers. And what we're going to do is we're going to then put those numbers in order. And so here are 16 people. So the first 16 people, the lowest 16 numbers are in our study. So I apologize to Megan, Abby, Amanda, one of our Samanthas, and Lauren are going to be out of the study. So right now, here are our 16 people for the study, right? So again, that was completely random. We used random numbers, applied them to people, and then went randomly from there, right? So that would be an example of simple random sampling. Now, systematic sampling is really the same thing, it's just more complicated. So here we're going to divide the participants by the number you need. So let's say you've identified 100 people who could be in your study, and you want to randomly choose 20 of those people. So what we're going to do is we're going to divide the potential participants, 100, by the number you need, which is 20. So we're going to divide 100 by 20, which is 5. And then we're going to use a random number for our starting point. So we'll go back to our random number calculator here. We're going to go back. We just want one random number, and we're only between 1 and 100. Right, we've got 100 participants. Oh, no, 100. Get numbers. All right, so our number is 89. So we're going to start with, so participant number 89 is in the study, and we're going to go by fives, right? Because 100 divided by 20 was 5. So participant number 89 is in our study. Participant number 94 is in our study. Participant number 99 is in our study. Participant number 4 is in our study. Participant number 9 is in our study. And we're going to keep going until we get our 20 people. All right, so kind of the same thing, maybe a little bit more complicated, and therefore maybe even a little bit more random, but really the same idea. Okay, so that's first we talked about simple random sampling, then we talked about systematic sampling. Now let's talk about stratified random sampling. So what if, for adults who stutter, we know that there are about 5 males to every 1 female for the adult population who stutters. So maybe for our study, we also want to get a 5-to-1 ratio. So we're going to take all the possible male participants and we're going to put them in group A. We're going to put all the possible female participants, put them in group B. And then we're going to use the random selection again. But this time we're going to use the random selection. We're going to take 4 males and then we're going to take 1 female. And then we'll take 4 more males and then 1 female. And then 4 more males and then 1 female. So that way we get the correct gender percentage in our study. It's still random because all the participants have a chance of being in the study, from each group. So all the males have an equal chance of all the other males of being in the study, and all the females have an equal chance of all the females from being in the study. So we can still call it random. It's just stratified random sampling. You could do the same thing for severity, right? So, just about all disorders, disabilities, all diseases, everything, right? Most people who have it are going to be mild. Less, or I guess fewer people than that are going to be moderate, and fewer people than that are going to be severe. So most people are going to be mild, and then fewer and fewer get as we go severity wise. So maybe, you want to get a correct percentage of, the right percentage in your study who are mild, moderate, and severe. Again, you could group all the milds together, the moderates together, the severes together, and then you can do the random sampling from there. And that's going to be stratified random sampling. Last way to randomize sampling is going to be cluster sampling. Here, so let's say we want to do a study on all kindergartners in the state of North Carolina. And we're going to randomly select 100 kindergartners from the state of North Carolina. And we go, wow, we do not have the financial ability to go to 100 different elementary schools all over the state of North Carolina. It's going to take too long. It's going to be crazy. So what we're going to do is we're going to randomly select 20 kindergartens, or maybe 20 elementary schools in the state of North Carolina. And then out of those 20 elementary schools, we're going to randomly select 100 kindergartners, right? So that's called cluster sampling, where you take everybody, you kind of divide them into clusters, you randomly select the clusters, and then you randomly select the participants, right? That way we know we're going to a maximum of 20 elementary schools and not 100, and yet still every kindergarten student from the beginning has an equal chance of being selected. Okay, I hope that makes sense. Then we've got, so the last kind of 2 things we're going to talk about is, number 1 is purposive sampling, which is not randomized. So this is what we were talking about when we were talking about qualitative research, right? So this is where we have, you want to study, 10 adults with autism and what it's like to have autism and to be a worker, or to be a lawyer. Let's say you want to get 10 lawyers who have autism, right? You're not going to randomly sample all the people with autism and then ask them if they're lawyers or not, right? You're gonna find lawyers with autism who are really good at talking about what being a lawyer with autism is, and you're going to say you are in my study because you're awesome at talking about this, right? So that's purposive sampling. It's not random. Again, it's what we're going to do most of the time in qualitative research and not quantitative research, although sometimes you'd use that for quantitative research as well. Last thing we'll talk about, and this I should probably made a new slide on this one, is the idea of random assignment. So with random assignment, right, you have your participants, and then you want to randomly assign your participants into groups, right, into group A and group B, right? So here we've got our 16 participants, right? So we did that. So those here are our 16 participants in the study. Let's go back. We're going to do random one more time. We're going to do 16 integers from 1 to 100. We're going to get those numbers. All right, here are our random numbers. Edit, copy. And then we're going to paste them there. Okay. Then we're going to sort based on those numbers again. So we're randomly doing it again. Right. So the first 8 people, and we would have decided this before, right? The first 8 people are going to be, in group A, and the last 8 people are going to be group B. All right, so there are our groups. So it's the same thing exactly, just instead of random sampling to get the participants for the study, we're doing random assignment to randomly assign, right, who is in which group. Okay, I hope that made sense for that. Last thing I believe we're talking about with participants and sampling is going to be sample size. And this is something we're going to talk more about as we go, when we talk about looking at data, forming data, analyzing data, getting inferences from data. As we increase sample size, that's going to increase representation, right? So if I get 20 adults who stutter in my study, right? Well, they're kind of like, let's say, the 3 million-ish adults who study in the US. Actually, there are 3 million people who stutter. So let's say there are 500,000 adults who stutter in the United States. Okay, I've got 20 in my study. Are they representative of that 500,000? Maybe. If I get 100 adults who stutter in my study, they're going to be more representative of that 500,000, right? Not a lot more, but at least a little bit more, right? So increasing sample size increases the representation, right? My 100 people who stutter are more like the whole group than our 20 people who stutter. However, it does not reduce the bias, right? So we already had the bias of volunteerism, right? Maybe people I've chosen aren't able to be in the study anyway, or don't want to be in the study, or couldn't care less that I'm giving people $20 because they don't need $20. It's not worth their time. Whereas somebody who might not have a lot of money, that $20 would be really helpful. So they'll be in it, right? But then we're not doing things equally, and that's crazy. There are also going to be a lot of adults who stutter who don't go to therapy and who don't participate with groups of people who stutter because they don't care that they stutter. So I'll never get them, right? So there's still the same amount my study has the same amount of bias whether I have 100 participants, 1,000 participants, 20 participants, right? I'm increasing my representation, but I'm not decreasing the bias. The bias is still there no matter how many people I have in my study. And then one more thing we're going to talk about today, and again, we'll talk more about these things later, is that too small a sample size has little chance of finding a significant difference and therefore might be unethical, right? So if I want to see whether or not people who stutter, let's say, perform as well at a speaking job, being, let's say, as lawyers in the courtroom than lawyers in the courtroom who don't stutter. And my sample size is 8 adult lawyers who stutter and 8 adult lawyers who don't stutter, right? Well, maybe there's going to be a significant difference there, but there's probably not going to find significance even if there is a difference. So maybe I'm going to say, oh, there's no difference between the performance of adults who stutter as lawyers and adults who stutter who are not lawyers. But maybe there is a difference, but I just couldn't find it because my sample size wasn't big enough. And if I had had 100 adult lawyers who stutter in one group and 100 adult lawyers who don't stutter in another, maybe I could truly find that difference. So if my sample, so that's a long-winded way of saying that my sample size of 8 people was too small. So I have wasted the time of the 16 people I had in my study. I have wasted the resources, the money I used, the time I used where I could have been doing a different study. So not only is it not a good thing to use too small a sample size, but it actually might be unethical to waste people's time like this to do too small of a sample size. So I believe that is the end of our lecture on participants and sampling.